As you'll recall where we left off, we had just completed running our reliability analysis on a set of items in this data set, and we found out that they were internally consistent. So let's say this represents one of the variables that you're interested in. Our next step is then to compute a variable using the average of these items. And in order to do that, we need to go to this option in SPSS, which allows us to compute a variable. We go to compute variable, and then we select the items that we wish to combine. So as you'll recall, the last set of items that we looked at in terms of internal consistency were 61, 1 through 5, and that was in the last tutorial. The way that we're going to do this, we're going to call this, and you have to actually provide a name when you create a variable. I'll call this example variable, or example var. And then we need to consider how we're going to combine them. So you can do this manually, or if you use this slide bar, you can scroll down to statistical, and then go to mean. And what this will allow us to do is create a variable that's derived from the averages of all of the items included. So this is going to sum and average all of the items in this, and these are all measured on a 5-item scale. So we'll take this one, and they're comma separated. So in the setup of this, it only provides 1 comma, but for every subsequent value that you enter, you have to add a comma in order to separate it. Add another comma, and add the 5th variable, and this is from our last tutorial video, and this will create a new variable, and it'll be called example var. So we select OK. And this is where something that we learned in the last video will come in handy. Remember, in the write-ups of our papers, we have to provide description. So we can say that a variable was constructed by asking participants to respond on a 1 to 5 Likert type scale to the following 4 or 5 items. And in parentheses, based on APA formatting and the conventions in writing and style, we would then provide the means, standard deviations, as well as Cronbach's alpha. And we know that from the prior video, Cronbach's alpha was 0.92. With the rounding, it was 0.915. So we can go to our new variable, example variable, and just as we did in the first video, I can go here using this icon and get the relevant information that we would need in order for reporting the scale summary statistics. So we know now the mean for this variable, which is based on the summed and averaged values of those 5 items, is 2.53, and the standard deviation is 1.17, which is fairly similar to what we saw in terms of the averages and standard deviations from the individual items that comprise the scale. And you can see that the maximum and minimum values are anchored at that 1 to 5, because this was a 5-point Likert type response set, which will probably be very similar to what you'll use. 1 to 5, 1 to 7, 1 to 9 are typically what we use in creating scales that are multi-item. So now when we report this, we could say variable x, was found to be internally consistent, and then we also would report these summary statistics. And this would be in the section of your paper that is actually describing your variables. In future analysis, you would use the summed and transformed variable rather than the individual items that comprise that variable. So if I'm looking at the interrelationship between this variable and another variable in the data set, I'm now able to say, so let's say this example variable, and I'm just using, very large omnibus labels here. Let's say this is attitudes towards learning online statistics. And then I have another variable that I'm interested in, and it's and we'll just call it numeric fluency, which is basically aptitude with numbers. And I want to know about the correlation between the two of them. And so let's say these last 2 variables represent that. So I'm going to use my example variable, and I say I have a hypothesis, and it's based on literature, that people who have higher levels of numeric fluency have more positive attitudes toward learning statistics online. Well, we can test that. And so if we want to say that it's predictive, we would use a regression. But if we're simply looking at this in terms of what is the relationship between x and y, which is the basic formula for using any or for creating any research question, we would be looking at simply correlating these two. And so we would look at bivariate. And if you want to be fancy, you can get bivariate correlations with confidence intervals. But typically, when we report Pearson's R, we just simply need to know bivariate correlations and whether or not they're significant. And so if I want to know if x variable is correlated with y variable, I can run this. And we'll go over here to our output. And we can see that the correlation coefficient, Pearson's R, is 0.397. And these are confidence intervals. If we want to know the p-value, which is something that you report when you're doing this for the formal write-up of your project, we would do this again, but instead of using the confidence intervals, we would go to bivariate, and then we would use the same two variables. Select 1 and 2 Pearson's. And if you have again, if this is a pure research question, you're asking what is the relationship, you would use two-tail. If you say there is a relationship, then that would be a one-tailed hypothesis test. Your options, it's always useful to have your means and standard deviations. And then we can go ahead and click OK. And as you'll see, the value is unchanged, but we also now know that the p-value is smaller than 0.01. And so when you see the write-ups, and as you've seen in many of the research papers that report statistical tests, they have a p-value that, p denoted by an italicized p, and then smaller than a value of 0.01. And so here you would have an italicized r equals 0.397 or 4.40 if we're using rounding, and p, italicized p, smaller than 0.01. So these two variables are positively correlated. And that's how we would be able to deduce that using these statistical methods. In our next video, we're going to look at this using a simple linear regression approach, which is just an extension of correlation, but it's actually suggesting that one is predictive of another variable.